Hello friends, this is AKHILESH Pandeey, Get AI Rating, and as I had promised that I'll start the tutorial for GATE exam, and so here I am with that. And the first subject that I have chosen to taught, and it is specially for electronics and communication branch. However, it may cover the portion of electrical engineering and instrumentation engineering as well. So the very first subject that I have taken is network analysis, and I'm going to start from the very basic chapter of the network analysis, and that is basic concept. So here it is, basic concept. This is the first lecture from my side, and in basic concept I will start the basic parameter of the network, and that is charge. Okay, so I think this all of the GATE aspirants will be familiar with that, but also I am introducing it as it is a basic concept. So charge is what? Charge is just the basic parameter of network, and how we can define a charge. Like in basic physics we have already learned it that when two particles are rubbed together, then the electrons being transferred from one particle or one atom to another atom, and this way one particle is positively charged and another one is negatively charged. Whichever gains the electrons is negatively charged, and whichever sends the means transfers the electron is positively charged. So this way we say that the transfer of electrons produces the charge. So the smallest unit of a charge will be of course electron, and so any charge can be defined as the quantized value of electrons, means it is comprised of number of electrons, and that's why the charge is defined as number of electrons multiplied with the single electronic charge. This is single electronic charge, which value is 1.6 into 10 raised to minus 19 coulomb. Its electronic charge value, electronic charge, and this and denotes the number of electrons. So whatever the charge will be there, either it is 1 coulomb, 2 coulomb, 3 coulomb, any charge, that will be made from the electrons, the number of electrons. So if we are said to find that how many electrons are there in 1 coulomb charge, so of course what we will do, Q equals to 1 coulomb we have, and that will be of course equals to Ne. We can directly obtain the number of electrons by just dividing this by the electronic charge, that is 1.6 into 10 raised to minus 19 coulomb. So whatever the value will be, so this will be the number of electrons that makes the 1 coulomb charge. Similarly, higher value of the charge can be made up. Okay, so this is about the charge, and of course the unit of the charge is coulomb. And if there is a question like the smallest value of the charge, then the smallest possible value of the charge will be 1.6 into 10 raised to minus 19 coulomb, because this is the electronic charge by which other charges has been formed, higher value charges has been formed. That's why it is the minimum value of a charge that exists. Okay, so this is the basic information about charge, and charge is basically denoted by Q. Now we come to the second basic parameter of network, and that is of course nothing but electron. And again, all the guest aspirants will be familiar with the current as well, but I am also defining it. So current is what? Current is just rate of flow of electrons, or you can say rate of flow of charge. So current is dq upon dt, means whatever the electrons or charge, you can say whatever it is. So the rate of change of rate of flow of charge will be called the current. So if there is a cross section, and through it, if the charge is flowing at some rate, at any rate, we can say that 2 coulomb per second is passing through it, or 3 coulomb per second is passing through it, then that amount will be called the current. So its unit will be either coulomb per second, or it is denoted as ampere as well. So ampere is the most used unit for the current. So this is only the definition for the current. Now This is current, and in network we saw the current source. How the current source is being shown? So this is shown as just an arrow. So this arrow denotes the direction of the current, means in this direction the current is flowing, and current is denoted by, of course, I denotation. So this is the symbol for the current source. Now when the two current sources are connected in parallel, then what happened? Let's see. The two current sources are connected in parallel, series. So when the two current sources are connected in series, then what happens? If I am considering that here 2 coulomb per second charge is being followed, okay. So from this point to this point, this much charge is flowing. So the same rate of flow of the charge should be in this part as well, because it is the same network path. So whatever the rate of flow from here to here, the same rate of flow will be from here to here. It means the current sources must be equal when it is connected in series. That's why I1 and I2 must be equal. So equivalently we can denote it as a single current source, and I1 must be equal to I2. So whenever the two current sources are connected in parallel, this must be equal, and we can denote it by single current source. We have not to denote it by different current sources. Now we consider the case when the two current sources are connected in parallel. Then what happens? Let's check. So when the two current sources are connected in parallel, let's check what happens actually. So these are the two current sources connected in parallel. So if 2 coulomb per second charge is flowing, let's take an example. 2 coulomb per second charge is flowing from this part, 3 coulomb per second charge is flowing from this part. So in 1 second, 2 coulomb per second from here, 3 coulomb from here. So 5 coulomb per second flowing from the entire part. It means when there is the two currents connected in parallel, then the summation of the current source will be in the equivalent current source. So if we denote it by an equivalent current source, then the two different current sources are being summed up. Okay, and the addition will be according to the polarity. Means if the arrow is in the same direction, means it is denoting that the current is flowing in this direction and this current is flowing in this direction. Means the overall current flowing will be added this time, but when the arrow will be in different direction, then we will consider that case as well. So according to the polarity, it is being added. For this thing, it is added directly, means I1 plus I2. But when the direction is different, let's check the other condition as well. When the direction is different, means take this one I2 and this one I1. Okay. So in this case, the equivalent current source will be like this. The arrow is same for I1, so I1 will be taken as positive. Arrow is opposite for I2, so I2 will be taken as negative. So I1 minus I2. So overall current source is again added, but according to the polarity, it means what? When the polarity is opposite, that will be taken as negative. Again, if we take the other case, like I1 is downward and I2 is upward, then in that case what will happen? So this will be the case. Here again current direction is opposite in the equivalent source, and here the I1 is opposite to that. It means I1 will be taken as minus I1, but for I2 it is in the same direction. The equivalent current source and the I2 current source is in the same direction, so it will be taken as plus I2. So the overall current source will be like this. So we have to understand this thing, that when current sources are connected in series, then they must be equal. But when it is connected in parallel, then in that case the equivalent current source will be the summation of the individual current sources, but it is summed up according to the polarity. If the polarity is different, then it will be considered as negative and subtracted, of course. So that's all for the current source. Now we consider the next parameter, next basic parameter of the network, and that is voltage. So here we start. Voltage, again the voltage we all know, I think, and I will try to introduce you again for the gate point of view, how it is important for the gate point of view. Voltage. We all know that voltage is nothing but the potential difference. The other name is potential difference, of course. So potential difference, in basic physics we have already defined the potential difference like the work done for bringing a charge of 1 coulomb charge from one point to other point will be called potential difference, and that is voltage. Means voltage is nothing but the work done per unit charge. So we can define voltage as dW upon dQ. Means if charge is being carried out, dQ charge is being carried out from this point to this point, and the work done, total work done is dW, then dW upon dQ is the voltage. And of course the unit of the voltage is volt, or from here we can find, or joule per coulomb is also the unit of voltage. So it is very easy to understand and to learn that voltage is nothing but work done per unit charge. Okay. Now again we come to the voltage source. So similar to the voltage current source, here the same circle is drawn. Okay, here I am discussing the independent voltage source, and just now I have discussed the independent current source. So in independent sources we used round circle, okay, the circle. But when we will consider the dependent, which is the next topic, we will see how the source is being denoted. Okay, so here as a simple circle is shown to denote the independent source. Okay. So plus minus, if there is a denotation like plus minus in a circle, then it is called voltage and denoted by V, of course. When, so this is the simple symbol denotation of voltage, but when the two voltage sources are connected in series, then what happens? Let's see. V1, this is V2. So here just we have defined that the work done per unit charge to take a charge from one point to other point will be called the voltage. So the work done per unit charge from here to here is V1. Work done per unit charge from here to here is V2. So overall work done from here to here will be, of course, the summation of these two. So if two voltage sources are connected in series, then the equivalent voltage source will be the summation of 2, and again the polarity will be considered. Means if here plus then it will be added. But we see the other cases when the polarity is different. Let's check it out. This is minus, this is plus. So V1, V2. Now the equivalent source will be what? Let's check. If we denote like this, the equivalent source. So in this case, plus, here plus, it means V1 will be considered as positive, but for V2, here on the upward direction it is minus and here it is plus, so it is reversed. It means V2 will be considered as negative, so V1 minus V2. And again we can consider another case. If minus plus V1 is given here and here it is plus minus V2, then for this case what will be the result? So for this case we have, if we denote the equivalent source like this, then here V1 is minus in upward, but the equivalent is plus in upward, so it is reversed. That's why it will be considered as negative. But for V2, here it is plus and here it is plus, so it is same, so it will be considered as positive. So minus V1 plus V2. This way we can combine the two voltage sources connected in series, and we can give the equivalent voltage source like this. Now this was the case for the series connection of two voltage sources, or more voltage sources we can consider similarly. Now the turn for the voltage sources connected in parallel. So let's check what happens when the voltage source connected in parallel. So here we have two voltage sources connected in parallel, plus minus V1 plus minus V2. These are the two voltage sources connected in parallel. Again, we have just defined the voltage as the work done per unit charge to take that charge from one point to other point. So work done per unit charge from here to here will be V1. Work done per unit charge from here to here will be V2. So we can see that these two levels are same, means this level is equipotential, this level is equipotential. So whatever the work done from here to here will be the same for as the work done from here to here. It means both the V1 and V2 or whatever the other voltage sources will be must be equal. It means for these two we can give a equivalent voltage source, single equivalent voltage source, and both must be equal. So if it is 5 volt, then this must be 5 volt, or again another voltage source, if there is another voltage source, then that will be again 5 volt. So in parallel voltage sources are always equal, and we can denote it by a single voltage source. We have not to denote it by multiple voltage sources. So this is all about the voltage source. So we just discussed charge first, then current, and then the voltage source. Now we will check a few questions related to voltage source that has been asked in the previous GATE exam. So let's check the question first. So this is the question we have. The question is from 1997, 1 mark question. And the question is like, circuit is drawn plus minus 10 volt, of course, and here it is plus minus V, 3 ohm resistance, and here it is a plus minus 5 volt, again a voltage source. And the question is the voltage V in the circuit is, options are 10 volt, 15 volt, 5 volt, none of this. So this is the question that we have. Now we can see here, just now we read that if the voltage source is connected in parallel, then they must be equal. Now here we can see that 10 volt is across this two levels. So across these two levels, everywhere there will be 10 volt voltage, right? So we have to determine this V. So of course, if here it is 10 volt, then here again it will be 10 volt. So we can directly give the answer that V equals to 10 volt. We have not to check whatever the current is flowing through this or what is the voltage drop across this. We have not to consider that, because just we read that there must be, if there is a parallel connection of voltage sources, then they must be equal. So here the voltage level is same across this potential, these two lines, and that's why if it is 10 volts, so it must be 10 volts. So V equals to 10 volt directly. So this is the question asked in previous GATE exam. Now we check the last topic in this lecture, and that is dependent sources. So dependent sources, just now we considered the current source and voltage source were independent, and they were denoted by a small circle, either current or it was voltage, it was denoted under a circle. But when we are considering a dependent source will be denoted inside a diamond shaped circuit, diamond shaped symbol, and if it is a voltage source, plus minus it will be denoted, and if it is a current source, then it will be denoted like arrow. So this is the denotation for dependent source, this is the denotation for dependent source, and this is the denotation for independent source. I think most of you will be knowing this. So dependent sources are how many of how many types? Let's check it out. So we have just learned the dependent source, so how it is being denoted. Now we will check the types of dependent sources. So here are the types of dependent sources. So the very first type is VCVS, voltage controlled voltage source. So first of all we have to denote a voltage source. So we will draw a voltage source, plus minus, of course voltage source is being drawn. Now it is controlled by a voltage, means controlling is also voltage, so it will be like this. AV means it is a voltage source and controlled by a voltage. A is of course a constant, A is constant, and V denotes the voltage, some other voltage. So it is controlled by voltage and it is a voltage source. That's why its name is voltage controlled voltage source. Now the unit, what will be the unit of E? Of course, the ratio of voltage, it is also voltage and this is also voltage. Sorry, this one is also voltage, V is also voltage. So A must be unitless. Now we consider the other case. If we consider VCCS, voltage controlled current source. So we have to first draw the current source. So current source is like this. It is a current source. Arrow will be upward or downward, anything. This is current source and it is being controlled by a voltage. So controlled by voltage means V. So V is again a constant. This is voltage V. So controlled by voltage and it is a current source. That's why its name is voltage controlled current source. Now the unit of V will be what? Overall it is current, means V is some current. So V equals to I upon V. I means ampere, V means volt. So ampere per volt, or you can say per ohm. So the constant of unit of constant V will be per ohm. So it can be asked in a 1 mark question that what is the unit of the constant in voltage controlled current source. So we will have to write it as per ohm. Now we will see some other type as well. Of course it is CCCS, current controlled current source. Current controlled current source. We will first draw the current source. So current source means arrow and controlled by a current. So of course controlled by a current, Ci. Again overall it is current, it is also current, so C will be unitless because the ratio will have no unit. Current divided by current cancelled out. Last one, CCVS. CCVS, current controlled voltage source, means we have to draw a voltage source plus minus and controlled by current Di. So overall it is a voltage, so Di is a voltage and D equals to V upon I. It means volt upon ampere and it means we can say ohm. So the unit of D will be ohm. So this way we just think that what is VCVS, VCCS, CCCS and CCVS. So these are the 4 types of dependent sources and I think there will be no confusion to understand these things. Now we will consider a question related to this topic asked in previous GATE exam. So here it is. Let's check the question. So these are the very basic topic of network analysis and we can see that questions are still being asked from these topics. So as I have mentioned in my videos that in GATE exam nowhere the questions used to be from advanced or higher topics. It is used to be from basic concept, but it may be somehow tricky. So you must understand the basic concept and do revision accordingly so that you can solve the questions easily in the exam. So here the question from 2014 and it is of 1 mark question. 1 mark question, right? So the question is like, first of all I am drawing the circuit diagram. Here it is I and here a diamond shaped dependent current source AI and a resistance is connected in parallel to it, and the question is the circuit shown in the figure represents A and the options are VCVS, VCCS, CCCS and CCVS. I hope that most of you would have already known the answer, and here we can see easily this is a current source as we can see by the arrow, and here it is depending upon II, which is current. So overall it is current source and depending controlled by a current. So current controlled current source and the answer will be CCCS. So very easy question, but sometimes in 2014 it has been asked, so it can be asked in the coming year exam as well. So this is all from my lecture tutorial, the first lecture from my tutorial series. and I will come with some other concepts, means sequentially I will come to the next topic in next video.